If you're ready to harness the power of your communications data, blast off with Nylas today.
Hey, Rem, how are you?
I'm doing good. How are you doing, Blog?
I'm doing fine, thank you.
I'm really excited for today's topic. I think we kind of went through it earlier, and I'm still a bit, it kind of woke me up a bit. So I'm excited to jump in.
Cool, yeah, this always some weird topic. So we're gonna talk today about stack-oriented programming, and this is the little joke that says that the mystery of my speech undercover is just an all-force programmer I was. So you're gonna see why this joke is actually funny. So jump in. So today we're going to talk about force and factor, which are two stack-based programming. So Forth is a procedural stack-oriented programming language that first appeared on 1970, which is like 52 years ago. And factor is just stack-oriented programming that appeared in 2003, which is like 19 years ago. It's kind of newer. And as everything, they can both be installed using brew, which makes it pretty much easier. So one of the first things about stack-oriented programming is that it uses Lifo, which is like last in, first out. So we have an empty stack, then we input 1, 2, 3, and you're going to see that it's get stuck, right? So whenever we want to print a value on the screen, it's going to always grab the last one. So if we input 1 to 3, when we print it, it's going to go like 3, 2, 1. So it's going to always grab it from the top.
Always reverse order.
Mm-hmm. Exactly.
Okay.
And then we have reverse Polish notation. So first operands, then operators. So in Python, we can say, for example, 4 plus 5 multiplied by 3. That's going to give us 19 because of the order of precedence. If we would like to execute the sum first, we need to wrap it in parentheses. So parentheses, 4 plus 5 multiplied by 3, that gives us 27. On factor, we do things a little bit different. We will say 5, 3, multiplication sign, 4, and plus sign. So that means it's going to grab the 5 from the stack, then it's going to grab the 3, and it's going to say, hey, I got a multiplication sign. Let's multiply them. And that's going to give us 15. Then it's going to say, okay, I have 15 on the stack, but I also have a 4. What else do I have? A plus sign. So I'm going to grab the 15, I'm going to grab the 4, and I'm going to sum them together to get 19. If we would like to do something like here in the parentheses, we simply need to say 4, 5 plus 3 multiplication sign. So 4 plus 5, 9, 9 multiplied by 3, 27. So that's probably a little bit harder to write, but it's actually easier in the compiler because the compiler don't need to check for precedence, don't need to check for parentheses, because it's just going to grab for the order that is in here on the stack.
Yeah, this is really interesting, and I like how you've kind of laid it out, where essentially, from a programming perspective, you can think of it as first you would assign your values. So if we look at the second last bullet in Forth, you're assigning your values 4 and 5. You're putting it in the stack, and then once you get an operation, you're going to say, now I need to apply this operation. I'm going to take the last 2 values and apply that operation to get 20, and then you'd apply the following operation.
Mm-hmm.
As well.
Exactly. Yeah. So that makes it easier. Of course, if you, for example, would say like 5, 2, 1 multiplication, it's not that it's going to grab those 3 numbers. It's actually just going to grab the 2 that are on the top of the stack.
Yeah. So you're always operating on 2 values at one time. Okay.
Exactly. So you will say, yeah, but what if I need to do something else? Then that's why we have stack manipulation. So, for example, here dub is going to duplicate the top of the stack. So if we have 5 dub, we're going to have 5 and 5. Peek duplicates the last item onto the top of the stack. So we have like 1, 2, 3. We're going to have 1, 2, 3, 1. Or actually, let me share my screen so we can see it here and it's more clear. So here, for example, we can go and call d4s and say, for example, we can say 1, 2, 3, and then can say peak, and then we can print it on the screen. Oh, I think actually peak doesn't work on force. I think this one actually works on factor. So let's retry that again. So with the peak, and then we input 1, 2, 3. So we have 3, 2, 1, and now we're gonna have 1, 3, 2, 1. So it's gonna grab whatever was on top of the stack and duplicate it on top. Then
I guess one thing to highlight is there are two different languages you can do this in. So there's one is fourth,
yes, and the
and
other is factor.
and these keywords here are for factor, which you just showed.
So most of them are gonna work for both.
Okay,
Peak only works for factor.
gotcha.
That's what here I'm saying that they might work or they might not work.
Okay,
Drop, for example, is going to eliminate the value on the top of the stack. Swap is going to exchange the top of the stack and the second item. So if we have like 5, 3, it's going to become 3, 5. And actually, we can do that here, I think, on force. Let me share my screen again. I think I stopped sharing it. So, for example, if we have 3, 5 plus, or actually minus, if we do 3, 5 minus, and then we want a period to actually print the value in the screen, it's going to be -2. But if we do 3, 5 swap minus, it's going to be 2. Because this one is going to say, okay, I have 3 and I have 5. And I also have a minus sign. So it's going to be 3 minus 5, it's going to be -2. But if I have 3, 5 swap, what it's going to say is, okay, reverse the order. So grab the 3, put it here, grab the 5, put it here. So now when I do the minus, it's going to be actually 5 minus 3. Because that was clear?
yeah, it makes sense. I'm thinking through in terms of how the stack works, but it seems like based on your processing speed, you just kind of run through the stack as you put input in. So you'd have input of all these values, and you would just start calculating them as you need to.
Yes, exactly.
So I'm trying to imagine a very large stack, but you're just kind of go through it one by one to get to the final result.
Mm-hmm. Yes, exactly. Also, we have something called language extension. So we can create words, and words are kind of like functions, but a little bit simpler. So, for example, we can create a word called expo, and its body is going to be dab and multiplication sign, which basically means duplicate whatever is on top of the stack and multiply it. So if we have 3, for example, the dab is going to duplicate it, so we're going to have 3 and 3, and it's going to multiply it, and we're going to have 9.
Yep,
We
sense.
also have another word, which is double, and it's simply going to say 2 multiplied by whatever we have on the stack. So if we have, for example, 4, we're going to say 4, 2 multiply, so it's going to become 8. But then we can also say double expo, which is going to call expo, and it's going to call double, and also it's going to do a carry return, and then the period is to print on the screen. So let's say we call double expo with the value 5. It's going to call expo. So 5 dab, we're going to have 5 and 5. Multiply, it's going to become 25. Then it's going to call double. What's on the top of the stack? 25. Multiplied by 2, 50. So we do a carriage return and then print the value 50. So let me share my screen because this is always better to see live.
So here we're essentially just defining functions and using those functions as building blocks to create more functions.
Yes, exactly. So here, let me call it double expo.fdh. Okay, so it's loaded. And I think it's called, I can say double expo, and then, for example, 5, and I press enter. Double expo. Let me check real quick. Oh, yeah, double expo. So let me see what happened. So I load it, which should be fine. Page. That's pretty fine. So double expo. And should be 5. I don't know why you get stuck under flow. Okay, that's weird. Let me check real quick.
Do you have the function that you created?
Yeah, it should be there. I don't know. It's stuck, remember. Everything needs to be in the right order. So that's what I made the mistake. We're gonna see.
Also, it's like we have to create expo first, expo dupe.
Actually, it's the 5 first.
Oh, okay. So it's 5 double expo.
Yes, exactly.
Gotcha.
Yeah, we're like used to call the function first.
Yep.
Here, actually 5 double expo, which is kind of weird, but then you see 50.
Oh, awesome.
Or I can say 3 double expo, and then 18. Because actually 3 needs to be on the top of the stack, which is
that makes sense.
complex. Yeah. Okay, let's see. So, kind of like wrapping up, we're going to see a full example of how to do a Fibonacci sequence using factor. So, how this will look like? If we input, for example, 10, it's going to return 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So it's pretty much grabbing the number, the value that is behind, sum them together, and then showing the value. So we're going to go into factor.
So with Fibonacci, we're just adding the last two numbers.
Mm-hmm.
And we start with, I think, 0 and 1.
Yes, it's always going to start with 0 and 1.
Gotcha.
So let me clear the stack first. We need to use Fibo. Then this is kind of like, so here I load the source code.
Yep.
I need to tell the compiler that it's actually need to use it. So now I can call the function. That's when I input for a number. So let's say I put 5, and it's going to return 0, 1, 1, 2, 3, and 5. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 3 is 5, and so on. So if I input 10, it's going to be 3 plus 5, 8, 5 plus 8, 13, 13 plus 8, 21, and so on.
So if you kind of like imagine it, you could see the stack starting with 0 and 1, and then I have a plus sign, and it would take that result and it would add it to the next number.
Mm-hmm. Yeah, and I have the source code here. So when we run it, I would say it's going to ask for a number, so it's going to select enter a number. We're going to read that number, and it's going to be a string, so we need to convert it into a number. And then here's kind of like the meat of the program. So we're saying 5, right? So we're going to have 5 on the stack, and we also want to put 0 and 1. So we're going to have like 0, 5, 1, 0. Then we're going to use pick, and pick is going to grab the 5, and it's going to add 1. So pretty much it's going to grab the last element from the stack. It's going to sum 1 because we want to have the number 6, because this is actually a loop. So it's going to repeat this a number of times. How many times? 6. So it's going to duplicate whatever is on the top of the stack. It's going to print it, and then it's going to do the over, and the over, it's taking the middle value and duplicating it. So we're going to do that twice so that we can sum the value. So in this case, we're going to do this. We're going to grab the value. We're going to duplicate it so we can sum them. So like 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, etc. So we're going to do that 6 times. And the drop, or actually the rod, is going to rotate the values. So it's going to rotate the top two elements. Then it's going to drop one of the elements. And then at the very end, it's going to drop the 3 last values of the stack because we already printed everything.
So the last thing in the stack would just be the sum. There, when the stack essentially ends, you would only have one value in it.
We're going to have 3 values, actually.
Okay.
That's why we use 3 drop. So we have drop, okay, which is get rid of the values of the stack, and 3 drop is like drop the 3 values on the stack.
Okay.
So it's, for example, probably we can do something real quick like this. Like, for example, we have 5, which is the number that we input in, and then 1, 0. So we have that in the stack, and we can say pick 1 plus. So you see, it's going to become 5, 1, 0, and 6. And 6 is the number that we want to use for the loop. So we can copy this. And see 0, 1, 1, 2, 3, 5. So if we do this again, probably we can do it a little bit more, kind of like to explain what's really going on here. And without the loops, just kind of doing it like once. So we have 5, 1, 0, 6. We duplicate. So we have 5, 1, 0, 6, 6. And we want to print. I want to print a new one. Okay, actually we'll leave it there. Like, there's a long time since I have done any fourth or factor. Probably if I try to explain it, it's gonna be worse, and you're gonna.
But one interesting thing to call out with the loop is essentially the square bracket that you showed. Everything in the square bracket is done those many times, starting with those initial values of 0 and 1. And the value that you want to go up to in terms of Fibonacci. So you do 5, 0, 1, and you run through the loop, and you essentially create the remaining values, and you print them out.
Yes. So actually, just because I don't want people to get kind of like a wrong impression, I actually have a very nice explanation here. Let me go real quick. I just don't want to go over time. It showed you this. Here's a really nice explanation that I did some time ago. And here it is. Promise it's going to be the last thing. So here. Yeah, so we're going to ask for a number, we're going to read the number, we're going to turn it into an integer, and we're going to use 5 as an input. So pretty much we have, like I showed you, 5, 1, 0, pick 1 plus. So we're going to have 5, 1, 0, 6. So pick is going to grab the 5, and then it's going to add 1 to it. And that's the number that we're going to use for the loop. Right? 6 we will use as a parameter for the loop. So it's going to be executed 6 times. And we're going to see this 6 because it's actually going to be used as a parameter for the loop. And that's why my explanation failed. Because actually you need to call the loop, not just have it there. And then this dab period over plus rod drop. So here we duplicate and print the first value from the stack. Over is going to grab the middle value and duplicate it. And we're going to call it twice so we can sum the values. Rot is going to rotate the top two elements, and finally drop is going to get rid of the last value. Times, it's how many times it's going to the loop be executed, and then tree drop, as I told you, get rid of the last three values remaining on the stack. And here you can see actually how it looks like. So we have 510 pick 1 plus drop. So it's gonna have like 510. That period over plus rot drop. So we're gonna have 501. We repeat that. So we're like simulating the loop. So every time we do that period over plus rot drop, we're gonna end with 551, 512, 523, 535. But when we do it like in a loop fashion, it's going to actually print the value that we want. And that's kind of it. Not easy to understand, not so easy to explain, but it's pretty cool. I mean, it really opens your mind to different things.
Yeah, this has been pretty cool to go through. I know you mentioned before, but we were talking about it. And where have you seen this kind of used in the real world?
Yeah, so amazingly, this is being used at Apple and at NASA and even in Kodak.
Yeah.
So it uses. Also, I think there's kind of like a telescope in Michigan which uses this. So I think they use it kind of like an embed programming language. So like for bootloaders and things like that.
Yeah, that's pretty cool. I was thinking the same. It'd probably be used for embedded systems where you just need certain instruction sets to be executed really fast. Yeah, that was awesome. Thanks, Vlad, for going through that. Anything else you wanted to share before we hop off?
Yeah, sure. Please don't forget that we have our channel where you can see all our live streams. And also you can go to the Nylas blog where we always publish a lot of interesting blogs in all the SDKs that we do and more. And don't forget that Oktoberfest is still going. We're almost there. We're almost close, but you still have time to go there and do a pull request.
Yep, we have 5 more days to go. Feel free to jump on Hacktoberfest, Nylas/Hacktoberfest/ or hyphen 2022. We'd love to see your contributions. So thanks again, Black, for walking us through stack programming. So I have a lot to think about.
Yeah, thanks. Always great to talk to you.
Okay.
Bye.
See you.
Bye. See you. Take care.